Hello and welcome to the third video in the LogicWorks series. Today we're going to be going over some of the simulation capabilities of LogicWorks. So to start with, we'll build a very simple circuit. We're going to grab this open collector buffer and place it right about there. Then we're going to put a binary probe on it and pull it out a bit to make it look a bit better. And we're going to put a switch on the other side. Now we'll go and we'll flip the switch, and you'll notice that the output from the open collector buffer goes from 0 to Z, which basically means high impedance. You can think of the high impedance as being undriven, and this allows you to set up basically multiple open collector or three-state devices, and they can drive a line to simulate a bus or wired and logic. So this just demonstrates that the simulator has multiple states. I believe there's 13 states in all, and high impedance is one of them. So once again, there's a demonstration. Okay, so let's continue building this circuit. We'll grab this guy, do a copy, and do a paste, and put another one just below him. And then we're going to wire them up like this. So click on the end there, guys, like that. And then we're going to take an inverter, and we're going to put it over here. And basically, we're going to drag that out and feed it back around. So we've got, and we need to do one other thing here. We'll move that along. And just as we did in one of the earlier circuits, we're going to put down a pull-up resistor. Rotate it with the arrow keys and put it there. And the +5. Okay, and I think what we'll do here is we'll name this fellow clock. And we'll flip that guy, and we'll see we've built ourselves a clock. Basically, the feedback causes the oscillation, and we can make use of it when we want to construct our own clock. Now, one of the other neat features when you're building a circuit to check out the simulation is that there is a probe, and if you click on this guy over here, you'll get a probe, and it'll show the values wherever you put the probe down. And it's a neat way of checking the values of a signal without having to put a permanent probe. This is sort of like a temporary probe, and you can probe around on the circuit. It's quite handy. LogicWorks uses an event-driven simulator, meaning that device values are only recalculated when the input change occurs. Thus, the speed at which the simulation occurs does not depend on the delay or other time values in the circuit. So it only does work when it has to. Okay, let's try something. Let's go back and review delays and setting them on a device. So if we click that device and we go up to the simulator and check, let's see, simulation parameters, we can increase the delay through that gate. And you can see that it has an effect because the timing waveform below changes, so that the delay through that gate has been lengthened, so therefore the duty cycle has changed. Okay, so let's keep building our circuit. We'll grab a 161 in this case, and we'll stick it right over here. And I think I want to move this whole thing here. So we'll move that over. Okay, now what I want to do here is grab a +5 to pull some signal inputs high. So I'll lay down my +5, and I will connect it to the pins I'm interested in pulling high. So let's do that. And we'll probably want this load to be high because it's normally low in the load state, and we don't want things in the clear state, so we'll pull that high. And as a good designer, we'll not leave anything undriven, so we'll put the ground down and we'll ground these guys. And what we'll do is we'll pull a little signal off there and we'll go to name mode. And we'll name that guy clock. Okay, just to check it's working, we'll put the probe on the end of it. And yes, it is very slowly, but it is working. So basically, that's another example of connect by name. This is called clock here, this is called clock here, so in fact, the signal propagates. Okay, I want to demonstrate another little option when you're naming signal lines. So let's start by pulling a few signal lines off here. And I just do this because otherwise we might accidentally select pin numbers as opposed to signal names when using the naming tool. So it's a little easier if there's these little stubs there. Basically we go over here, we get the name tool, click here, type in D0, and then we hold the Option key and the Shift key, and we click on the next one. Whoop. Didn't work. So let's back up. That didn't work very well. So we'll undo it. We'll start again. Name this guy here D0. And then we hold down the Option key and click on the end of this one. And you'll see that it automatically names it and increments the numeric part. So that's the kind of cool thing that I wanted to show. That comes in really handy when you're doing a lot of repetitive address lines or data lines. Makes things a lot easier. Okay, let's terminate that particular mode. Now we're going to go back and select this 161, and we're going to go up and try and do simulation parameters. And you will notice that you get a message saying that you cannot set the parameters on a subcircuit device. You might be asking why. We could do it on an inverter. Well, the reason is that this device here actually contains a subcircuit, whereas this device is a primitive. So if we want to see the internals of a subcircuit, just double click on it, and okay, now we're going to go over here and click on this device and go into device info, and we're going to turn this off, lock opening subcircuit. And the reason is I want to show the subcircuit for this device. So now if we come up and we double click on it, it asks, do we want to open the device's internal circuit? And we say, okay. So there is the internal circuit for that particular device. And the reason I show you that is to basically indicate that LogicWorks supports hierarchy, and that you can build up devices out of other devices, and that hierarchy can go to multiple levels. There's no real restriction other than available memory. Okay, let's look at pin delays. Now if we go up here and click really close in where we clearly got the pin and not the signal that's attached to it, and you'll see that it turns black in a kind of a T form. Now if we go up here and select simulation parameters, we'll get another delay that should look similar to the one that we had when setting the delay on a device. Only this time we're setting the delay on an individual pin. So we can increase the delay or decrease it. So you have the option of setting the delay through a device if it's primitive. If it's a subcircuit, then you have to set the delay on the individual pin. The nice thing about this is that it means you don't have to open up the subcircuit and change the delays on the devices that make up that particular 161. So it's kind of handy that way. Okay, let's start the simulator back up. And probably a good idea if things aren't looking right in the timing window is to do a restart and clear unknowns. And that usually straightens things out if they've gotten into an unstable state. Now let's go down to the timing window. I just wanted to show one other thing. That is that you can move the signals around if they're not in the right order. So you can just click and drag them, and put the clock on the bottom, and we can redo the numbering so that it's from D0 to D0, D1, and D2, like that. So it's really easy to change the order of the signals that are being displayed in the timing waveform. Okay, another neat thing is if you get a lot of signals in the timing waveform, it may be getting a little crowded or hard to read. One of the things you can do is group signals. So if we select this guy, hold the Shift key down and just select them all, and then right click and say group, we will get all of those signals grouped, and basically instead of a waveform we get the values that group makes up. So it's quite a handy feature, and of course we can go over here and ungroup, and we get back the individual signal. So it really depends on what you're doing at the time, whether you want them individual or grouped. Okay, let's take a look at this trigger button here. And this is where you're going to set up a trigger. So what we're going to do here is we're going to monitor the clock line. And we're going to say when a clock has a value of 1, we want to do something. In this particular case, we're going to put up a reference line. But we could do other things. We could have it beep. We could have the simulator stop. We could turn the timing display on or off. We can say that the condition occurs immediately or after some period of time. But anyway, let's just stick with something really simple here. And you will see that you get reference lines on the every time the clock value becomes 1. So triggers are really handy. Okay, I think that's about it for video number 3. Thanks for watching, and do come back and see video number 4.